She would call me a fuck mom. She won't be mad. I'd be mad.
Yeah.
Yeah, people will really take my tool off.
I think starting first.
I never remember what, because the assignments are so long.
I suppose that's how great.
I know the one on the.
Sorted.
Yeah, mine was.
It looks like that is this year. Yeah, it's surprising. I took a class. She yeah, if I do that, I think it also. I don't know how much it's Yeah. 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 I just started.
In a real life situation, you just
You can like. I gotta go back.
I think they want everybody.
Yes.
I just want to know how to fix it. I didn't want
Right now,
to
Yeah, you need a space. Yeah, return.
Yeah.
Return is basically returning a value. Because I don't. Like it can return states, but it has to have. It just goes wrong. Not five minutes. A little bit. Slap it on a little bit. Yeah, I don't really wording. But then would you get the flowers? Is there anything in that cooler? Yeah. Open it.
Oh, yeah.
Is there water?
Yes.
Oh my God. I'm dying. Thank you, science. But that was before you had this, right?
All right, good evening, everybody. We will get started on the night. First thing that I wanted to cover, to make sure everyone's on the same page, are what assignments are due and when they are due. Because there seems to be some confusion amongst everyone about what's due, when it's due, how many assignments are left until we get through the end of Unit 1, when will Unit 1 end, and I have the answer to all your questions now. So today is the 14th, so last night at 11:59, I'll assume everyone turned in assignments 6 and 7. I could verify that, but I'll just make the assumption that everyone did. So starting with today, you should have prepared and read about strings. And then we're going to go over a studio like we normally do. Thursday will sort of be very similar, what we've normally done, cover a class. Sunday, again, there are 2 assignments due, just like last Sunday. So yesterday night. Next week is where it starts to get a little bit different. I would recommend everyone basically starting today and the rest of the week and over the weekend. if you want to take a crack at this using Python locally before next Monday's class, you have until the end of class next Monday. So if you try it at home and you hit a snag or something is you're not quite able to figure it out, that's fine. We can help you out once you get back here next Monday. But after next Monday night, we will start running a lot of the Python code directly on our machines, which will actually make it easier for you to test various different pieces of code out, and you'll not run into as many errors as you've seen on the website where it says it's running out of time because it's not able to finish. So we're gonna cover installing Python on your machine and running it on Monday, but if you can try to get that done before Monday, you'll be a little bit ahead of the curve, because if everyone comes in without it installed on Monday, we likely will not be able to finish with everyone having it installed. So if you could take a look at that assignment. The reason that it has a picture of an elephant on it is to indicate it is a large assignment, so it might take a little more time than the other assignments have taken, depending on your experience level with installing programming languages on your device. There is no class on Thanksgiving because that wouldn't be very kind. I'm going to, so I published out this crypto assignment that is due by December 11th. This is also has the elephant next to it to indicate it is big. So this assignment would be good to sort of start looking at. You don't necessarily need to start, but the reason I published it is so everyone will be aware that it is due on that December 11th date, and you may want to start looking at it tonight. So tonight we're gonna have a little bit more time than we normally have had because the strings chapter is not as, there's not as much to cover as there has been in other chapters. So one of the things I want to try to do tonight is give people a little bit more time so you can take your first look, might be your second look at these two larger assignments. There will be other assignments published. I'm going to publish the remainder of them after Thursday's class. And the reason I'm waiting is so that everyone takes an even pace at what you're doing. Because if you work too far ahead, by the time you get to class, you're using code and other concepts that you haven't been taught yet, technically by the curriculum, and what that causes is for you to use features of the language that are not yet there, which then doesn't help the exercises in the book and in the studios to sort of exercise and use the topic that was just covered. So for instance, when we were doing the for loops, before we had learned control statements, the control statements being the if statements, a lot of people were using those if statements to help their for loop out. But the reason that we specifically did not cover those control statements first is we wanted everyone to be able to figure out how, if all you have is a for loop, to better understand a for loop so that you can stop going over whatever your list you're going over. So in the example I had last week where I was taking all the fruit and my fruits, rather than have some sort of if statement in that for loop say, oh, I don't want to look at fruits anymore, know that you have to go over all of them. And if you ever want to leave that early, you need to return. But you have to find a way to return that doesn't involve an if statement. And that was sort of an example of why working, if you work too far ahead, which is why we haven't published everything, you don't get the advantage of having to work around a problem with a limited set of tools. Because if you have all of the tools up front, which you will at the end of the class, but if you start using all of those tools before you've had a chance to really develop the skill of using each one of them individually, then it makes it harder once you get further along and you are just programming something straight out and you do have all the tools. If you don't understand each one of those well enough, it's kind of like if you had a toolbox, you have a hammer and a vice grip and a wrench and all your other various tools, and you just know they exist, but you haven't really specially used one over and over just to see how you can use it in different scenarios. Same thing applies to programming. If you haven't tried each one of those tools, the for loops, the while loops, the if conditions on their own just to see what they can do. That same way with a toolbox, if all you have is a vice grip, you haven't used a wrench before, then you'll end up keep falling back to one tool or the other when it's not necessarily appropriate. So that's a reason we're not constantly releasing all the materials. But I will, for the benefit of people who I know a lot of people over Thanksgiving wanted to be able to try to work ahead because they would have more work to do at the beginning of December. It's totally fine. So I will publish all the rest of what we're going to cover after this Thursday's class. So does anyone have any questions around assignments or when they're due? And if you do have any questions, you don't feel like saying it, feel free to send a Slack message to our Hello KC group, or you can email me or your teaching fellow.
You did good.
Oh, now I comprehended what you said. So this is what it looks like. It's really small for getting Python locally, but the real work is actually over here in a link, and there are 3 YouTube videos on there. One for Mac, one for Windows, and one for Linux. I don't know of anyone in the class using Linux. If you are, that's fine. Just to show where that is. So for getting started, we're gonna still, like normal, talk amongst your group and give time for all the teaching fellows to take attendance. And specifically within your group, try to think about how the strings have related to the other sort of objects we've covered so far. So when we were using the images and the pixels, they had methods on them, what are called methods. So you did dot, like get pixel, or dot get green, get red. Think about that and how on the different ways that it mentioned the strings have functions you can use as well, like lower, upper, there are other various functions on them. And how they relate to the images and the pixels there, as well as how they relate to how you can use them with a for loop or a while loop, how they relate to the lists that we've used before. Cover that in more detail on Thursday, but I'm just curious what sort of parallels people can draw so far just from having messed with the lists and the strings so far. But we'll come back together and I'll go over them in about 15 minutes. But I want to give everyone a chance to take attendance as well. Oh, also, if you're having trouble with any of the assignments or examples, this is specifically the time to talk through those with your teaching fellow and the rest of your group. I've not made that very clear in the past. That is one of the main purposes of this, sort of starting 10, 15 minutes. Width. That's right.
Yeah, just looking at the analyze text here.
Yeah.
No, that's where it's at.
I had it in here.
Summertime.
Because I thought that was the problem.
Important thing in this case is to figure out why, or understand why it's not working. Why this is
Well, this is there's nothing. There's like one in each section. After working there for 2 years. I'm just like, I had this, I had that. The fries are good. Like something.
No, that's it. I'm saying. So, if you like
Wrap that.
Yeah.
Oh, I see.
Yeah, I don't.
It's expected. Yeah. So.
Oh, okay. You do that. Okay.
Yeah. Which one? One we had Hillary? Oh, I figured that out. Yeah. Basically, you got to make it a real range of what it's in like, so you can do. You can minus the pixel one spin, you can add it. Let me see your color. Yeah.
Yeah. Okay.
Well, one thing you try is instead of doing yeah, try that. I mean, it's text, but we can already. You understand how that's fine. It's strictly.
Oh, yeah. I've done two. I don't know.
Oh, hey, look there.
Yeah, I don't know. And others.
I heard, I saw something, I thought it was
Not just
Not very. Yeah, that's right.
So I know this is right.
That's comments. It's gonna do something.
I mean, which kind of is.
Lots.
It was freezing.
So when you have your
And she would like, she would control a lot of the. She could take over
I'll change this now.
Oh. Got excited. Ready. Ooh, it works. All right. We will get started with strings. And I'll try to cover what actually a number of people have brought up. All right, yes, that's better. I can hear myself now, so it usually means everyone can hear me. If you can't hear me, like wave a hand. All right, no one did. I assume. Well, actually, you wouldn't know to wave a hand because you couldn't hear me. No, it's funny just for me. There we go. I am also live streaming like I did last time. It's in the Slack channel. I have the link in the Hello KC Slack channel if you want to see what's here. I think next week, and maybe Thursday might be the first day. I think by next week we're working to try and get those side TVs working. So you can actually see these further back without having to pull out a pair of binoculars. So we're working on getting side TV so people in the back can have a closer view of the screen. The three main things that I want to cover as we go over these examples tonight are, one, different ways of getting pieces of string and ways I would recommend doing it versus different ways that the material sort of said you can. Sort of like a lot of things in life, you can do something, but just because you can doesn't mean you should. And then I want to cover some reasons on why a lot of these examples, you would actually do them. So a lot of the sort of work through the examples in the text at the end of the chapter are legitimate problems people would do in various different ways with strings. Strings are sort of the base type that's used in almost every program. Not just programs, but a lot of the times on websites, what the website gets, generally it just reads a giant string, and then it determines based on that what in that string will be an integer, what will be a float, and then getting it further in so that it can say, if you go to put your address or something in, it reads that and then it codifies it into something more concrete than just random characters on a screen. So that's where strings are sort of the base building block of any website that you've used. So they are very important. You should get used to them because you're going to use them a lot in any sort of programming that you do. It's also how you get information to and from your users. It's always going to be a string. So the example I wanted to show here, sort of the initial. I'll zoom in on just a little bit more. There's not a lot of code there. I lost my cursor. There were two ways that it showed getting a value out of a string. Specifically, it mentioned how you can always get the last value. And getting the last value of something is actually fairly common, which is why Python has a shorter way to do it. And actually, a number of other programming languages also have a similar syntax for getting the last item in a string. So to make this a little bit more readable, and so the length function it mentioned gives you how many items are in the collection, which in this case is a collection of characters in the string. So if you want to go a little further so that you can see it, call that number of characters in fruit. So down here, this would go and print out the last character, but I also want to print out the number of characters. That'll be the number of characters in fruit, the word, so apple is the fruit I chose. What this code does is I get the length. And the reason that you always do this -1 before you go and try to use it is because the strings are always indexed, what's called indexed, starting at 0. So above here, the A is at 0, 1, 2, 3, 4. So if you try to access the character at 0, you'll get A, 2, P, 3, L, 4, E, 1, P. I skipped over 1. So you can see that same thing down here. If I go and get the character at 1, so as we saw, the number of characters is 5. The reason that matters is as you go over and access each value of the string, you may know that there are 5, but if you attempt to get the 5th character, which does not exist, you end up getting an index error. String index is out of range. So in Python, when you're writing code, and you generally, if you see something that says index error, what it means is that you, almost every time, it means you've written something with brackets and put a value in there. It could be dynamic, like this one is, where you put brackets in, so the last item location. Could be dynamic like that one is, or it could be that you put it's called a static integer there. So dynamic just means its value could change. So that 5 that it was initially, if I go and change this to be cranberry, those values all change. And I actually don't end up with an error because there are more than 6 characters. If there are 6 characters or more, there are actually 9. But this grabs the 6th character in the word, which is E, right here at index 5, which won't go up to 9. So keep that in mind anytime you see index error. So if I try to go up to the number of characters, this is a surprisingly common mistake made in daily development. These what are often called off by one errors, very common. And if you do happen to go into software development, you will be surprised how often you see errors like this, where someone should have known, oh, I should start counting at 0 and not at 1. So by counting at 1 here, we end up out of the range of the fruit, and we get this index error. Does anyone have any questions about accessing the characters in a string?
Numbers in that way.
I believe you can. Here's how we find out for sure. So the question was, we had the ability to do this. So you could say start at 0 and grab up through the first 2 characters. And then we can print new fruit. The question was, is it possible to do something like go through these up through the 4th to last? So use a negative. And that 0 is redundant because it defaults to 0. So I will remove it. We will find, I'll make this easy so you can read the output. New fruit. Second fruit. Char fruit. Last ones I'll just leave for fun. So you can use negatives, and that actually can be useful depending on your application. One of the main uses of like going over a string and checking the various characters within it is validating user input to a website. So you probably get really annoyed when you go to type a password and it keeps telling you you don't have the right characters. You need another uppercase character or an ampersand, some kind of @ symbol in your password. Likely there is some sort of function underneath that's going over your password and checking that each one of those criteria is met. That is one of the reasons you would go over and check a character in a string.
You put negative on the first side of the goal.
You can, I believe. So if I did -8. And it's not going to care until you go too far out. So -9 still works because -9 brings you down to 0. If you go to -10, ooh. That makes sense. Yeah, because there are no characters there. -9 is none. And you get it back. So that's interesting. I was unaware of this behavior on the first one. It goes back that far, but there's nothing there. That is interesting. I'm actually going to look at that more later. I would not have expected that, so I'm going to actually look at that on my own later. I'll report back. Because I would have thought that would have erred, because there is nothing located at that position in the string. So I would have expected an error there. Try not to use a negative in the first one, because that could be confusing. Especially confusing if you do something like that. gonna go start at the 5th one and go up to the 4th one. There are no characters in this range. But you can go negative. Keep this here for posterity. Any other questions around accessing? And the different ways you can sort of create the strings using the colon operator there to do what's copying of your string, a sub piece of it, a substring. Alrighty, next up is the string comparison. So I mentioned this in the book around checking if two strings have the same value. The specific thing that mattered on checking is that these two values are not the same. That's because it's a different function name. So I talked about in the book how internally the computer looks at a string and looks at each character in that string to figure out what it is. It goes and translates it into a number. So anytime it does comparison, it does it with those numbers internally with itself. So anytime you check to see if two strings are equal, converts them to integers and checks to see if each one of those integers is equal, which is why what you would normally do in this case is you'd want to, if you didn't care about the uppercase A and the lowercase a, it's where you do something that's called normalizing them. Which I have an example down below. An ORD is an example of a built-in function, so much like print is another one that we've used. Sum was another one that we had mentioned 2 weeks ago around adding all the integers or floats in a list together. ORD is another one that's built into Python. So if you're ever curious about how to find that, you can go to the functions page on Python's website. The reason, so every time I've gone to this page, I've gone up here and I've changed this little drop down. Once Python is installed and you're running the assignments and different code on your computer, be sure that the Python version you are running on your machine and the version number you see up here in this dropdown are the same. Otherwise, when you go and you read the documentation that says what each thing does, there's a decent chance that you go to do something, but it's a mismatched version between here and what's on your computer. So when you read the docs, it won't really make sense. Sort of like if you have a 2004 Honda Civic and you got a manual for a 2008, and you try to read how to replace a taillight, it might be the same, it might not, depending on how they manufactured the two cars between those 4 years. Same thing is true for the documentation for different versions of Python. I always go to the 3.5 version, whichever one that is, because that is the latest, what's called stable version of Python. And all that means is that it's guaranteed to work. Python itself is guaranteed to work for everything that is in the language. If you go to other releases, they're called releases, each one of the different versions. If you go to other ones, like this one says dev, what that means is they're actively making the newer edition. So don't look at that one because it may not work when you go to try to use it. So when you do finally get here, you look at the documentation, make sure you're on the right version, and then come and look at the function that we wanted to see, which is ORD. I'm bad at reading, so I always have to search in the browser. So this goes here and it says that given a string representing one Unicode character, this is actually something that is different between Python 2 and Python 3. And you don't really care currently, and you likely won't care for a while, what the difference between a regular character and a Unicode character is. If you're reading the Python 2 doc, it won't mention anything about this thing called Unicode, and that doesn't matter. The main difference is that in Python 3, it takes care of all of that for you, so you don't have to worry about it. In Python 2, you do actually have to worry about what a Unicode character is and how you use it, which is one of the other reasons I recommend once you do download Python, get it running, download Python 3.5, latest version. That's also what the download docs recommend. So what this does is it goes, you can read it, you get an integer, you get a string character, and it tells you what its Unicode value is.
Gary, is there a way to check for multiple ordinal values at the same time? Like get the individual values for char, p-e-a-r, all at the same time? Because I've tried several different ways to try and string those together and it doesn't work for me.
Yes, so the question was, is there a way to call this ord on a whole string? So if I was here and I had, we'll call it new string, I'll just write my name. Fun, I'll even throw in the old bonus character in there. How do I get the ord for each one of these? So if I just do it on the whole string, I'm actually pretty sure this is going to break. And I was correct. So what it's saying is it has a type error. One of the three possible errors that are common: type error, semantic error, and syntax error. So the type error here is that ord expects a character. However, it got a string instead. So in order to get a character out of your string, in the same way that we've gone over lists, you would say for character in that new string, except you want to get the character. And what will happen here, this goes over each one of the letters in my name here. So for character in new string, it's kind of a poor name. We'll just call it name. We go over each one of the characters when we print its value. So if you want to make that a little bit more clear, you could say print character. And you can see the value each one has next to it. The book actually covered that the space is 32. If you're really curious, these values map to what's called an ASCII code. If you really want to read more in depth about it, you are welcome to. You don't need to. But if you were really wondering, these are what are called ASCII values. And that is a standard that was, I think, made in the 1960s or 70s around what the Latin characters, so all the characters you would use in languages like English, French, Spanish, those specifically characters you would need in order to print out anything spoken in those languages. So this little accent character still fits in there in that group. But question was, how would you get each character in a string? And you do it by going over each one of them. So the same way you go over a list, this in operator, when you use it with a for loop, always says for each item inside this thing over here, I want to do something. In this case, for each character in the name, we want to go and print the character with this handy little colon to separate it, and then the ordinal value is actually what the ord is short for. It's the ordinal value. And then the initial example here showing that A and A are different. So here, the one that I had worked up before class, what I wanted to do was get the first and second word that were passed in through user input. So that's the way that you will get most of the strings in your program, is through a user doing something. Generally, even if you've moved further along and you've heard about people talk about databases, even the information you get out of there is often a string, even if you want it, you think it should be an integer or a float, because you think that when someone stores dollar amounts, they should be stored in the integers and floats. They may or may not be, depending upon who decided to store them there in the first place. And to begin with, what they had to do was read someone's string input initially and decide what integer or float to store it as. Which is why it is important whenever you read user input to make sure that if you do any sort of comparison, you're doing a process that a lot of people refer to as normalizing the input. A good example here is a lot of the times when you log into websites, your username case usually doesn't matter. So I'm not sure if it still happens this way, but Facebook and Twitter are examples of sites that did not at one time care. So if your username, so in my case, my username for everything is my first and last name put together, I could have done something like this and still been able to log in because they go and they normalize it. A case where almost every website still does this normalizing is on your security questions. So at your bank, you'll normally, the last one, like, what street did you grow up on? Or who is your favorite kid? That's everyone's favorite question. It will lowercase or uppercase, generally, whatever answer you give in those scenarios, because what has sort of been found in the industry with those security questions is, one, most people don't actually remember what they did. And two, the biggest one is that you may write, so if it asks sort of what street did you grow up on, you may write it like this one time, but then another time you may not realize that you wrote it without using a capital M and a capital S because you weren't thinking about it. So this is where normalizing comes in handy. I don't know if normalized is a verb that people regularly use. It's probably not. But when programming, normalized is used often to signify that you're taking two things, running them through a process to get an output that is similar between the two. So what's happening here is I'm calling this function. Mentioned it earlier on the strings. Whole bunch of built-in what are called methods, actually in this case. But they are just functions on the strings. Call lower, and what this does, as you'll be able to see, it takes the text and it makes it the lowercase equivalent of that value. So in here, if I come in here and I say my first word is apple, and I say my next word is apple, I come in here, and this is something else I wanted to show. You can do something that's called Boolean assignment. It's really just an assignment statement, the same as anything else. Up here where I went and said what street and another street are equal to a string, you can do the same thing with to get Boolean values. So over here I say normalized first word is equal to the normalized second word. Is it equal to? Sort of the question that happens here. That gets this evaluates to a Boolean, either true or false. So normally you would see this in an if statement, but you can run these anywhere within your code. So if you just need a value. So in this case, the main reason I did it was because if I zoomed in, you wouldn't be able to read it all in one line there. So I brought it into its own line here so it'd be easier to read. So you can say are words the same? So then this sort of reads out here, the strings are the same once normalized. And then you have a Boolean variable at this point that says are words the same to indicate that will have a true or false value, which it gets assigned from right here. So it comes here, says the first word I typed in, second word I typed in, normalized, this is what they look like. So calling that 2 lower on each one of them. And then this says they are the same. So if I typo it, you get false because they aren't the same. But the main reason you would care is you want to take that input and ensure it is the same between the two, because most of the time when you take user input, you don't care if it's all capital or all lowercase for most things a user puts in. Anyone have any questions around normalizing a string and comparing them together? All right, the next thing I wanted to cover before we go on and start trying out the studio is it mentioned in the book that strings have a property that is called immutable. And what that means is that you cannot change the value of a string. And this may be confusing at first when you go to it, because as you'll see here, and I'll actually print this out. Right here on this first line, we go and we say that it's not changeable. We print it out and it says it's not changeable. And then I go and I take the exact same variable and I assign it a new string. And it says that it actually let me appear to change it. But then on the last one, it does not allow it. And that's where it says type error, string does not support item assignment. And the same thing earlier, whenever I tried to assign a value, when I got the exception up here, that type error. Oh, I got an index error there. Oh, I'll remove that type error. That's too bad. All right, whenever I was calling ORD, I got the type error because it does not have that operation defined, or does not have an operation defined for string types. But a string is actually a collection of characters. And so the reason I want to cover this in a little bit more detail than some people may want to is that this is actually fundamental to the way that Python and many programming languages work. Is that right here, where I have this first string cannot change, and I assign it to that other string. Right here, this is a variable that is pointing at a string called I am not changeable. And it's its own variable there. And Python allows you to do what's called variable reassignment, which we covered previously. So here, all I am doing is I am saying, all right, I want to take the variable I assigned up here to I am not changeable, and I want to assign it to a different thing, in this case, another string called a different string is okay, but why? To sort of reiterate, Python allows you to do any type of reassignment that you want. So I changed it from a string to an integer, back to a string, and it didn't care. The reason it doesn't care is I'm reassigning the value of this variable. Now at the bottom down here, and what we had covered before, what I'm doing here is I'm attempting to change a character value within the string collection. So what we had previously mentioned with lists, so if I had, we'll call it set of values, and I go and print these, this goes and prints out 1, 2, 3, and 4. In the same, so this is where it will be different. Here I can go and say, on a list, because lists are allowed to be changed, you can go and change their value, because all that a string is a list of characters. It's how Python represents it. It's how it figures out what to do. But whenever you have a list of characters, is not mutable. That's why it mentions that strings are immutable. So what I was doing, these first 3 changes here, I mentioned this before. I changed the variable, string cannot change, 3 times. But at the very end, when I go to change one of the characters inside of that string collection, that is not allowed, because you are not allowed to change a string. So what this is saying to do is it's saying to go and take the string at the 7th position, go and take the character at the 7th position in the string, which would be 0, 1, 2, 3, 4, 5, 6. So it'd be this E. It's saying to go and take this E and assign it the value this where. Python does not allow you to reassign strings, because that's what you're doing whenever you're saying, I want to take the 7th character, I want to reassign it this other value. You're no longer doing variable reassignment at the point that you're saying, get one of these characters. You're trying to change the value of the character at that point, which is not allowed. And that's what is meant by a string being immutable. So right here, what you're changing is the variable. You're changing a variable called string cannot change. Down here, what you're doing is you're saying, I want to change the value of this variable at position 7 to this other thing, which in this case is another string. The reason you can't do this is you went from saying, I'm going to reassign a variable, to I'm going to reassign a variable's value. And in this case, strings are immutable, and a string is the value that this has right now. When you go and say, hey, I want to change the value of 7, it goes and says, oh, your value is of type string. That is not allowed. We've not defined a way for you to reassign a string. Does anybody have a question around that? Yes?
You assign it one single character.
So you could reassign, same as we did before. You could go, question was, can you assign it a single character? You can go and reassign the whole thing to a single character, and it will be fine. That might be confusing, so I'll assign it to a character that actually looks like one instead of printing out looking like an integer. So the question was, can you go and assign this to a single character? And the answer to that, as you will see, is no. So it points out where the error is. Same thing what's happening is there's an attempt to take a string and reassign it, which is not allowed because the string is, you're trying at that point to reassign a value. That would be the same, which was also not allowed, as doing something like this. Which, this comes out to a syntax error because you're at a syntactical level, this isn't allowed, but you're not allowed to reassign have in there. Internally, Python has to pull a little, it has to go further than just reading the syntax. It has to go into what's referred to as the grammar. So if you remember from elementary school, whenever you wrote, you first learned the syntax of just writing sentences, and then you later learned the grammar, which was where you put your subject and predicate or verb in a sentence. That same idea, Python comes in here and it reads this and it says, oh, okay, you have a variable called string cannot change. I want to grab the 7th character in that variable and I want to reassign it something else. At that point, it goes, oh, I have a rule that specifically says you're not allowed to reassign characters. Because what would happen in here, so these characters, as we saw in the example above, each one of these characters have an ordinal value, and internally in the computer, when it's doing anything with those characters, it's primarily actually just using these numbers. If you were to go and change that under the covers, you're fundamentally changing how Python works. It would work out to being the same. So if P is equivalent to 80, right here, so it's the same value as having P or 80, whenever you're working with strings, that would be the same idea. With integers, you're not allowed to say 80 equals 10, or rather 80 is assigned the value of 10. That isn't allowed. In the same way, when you go here to a specific character in a string, you can't go into that string and say, hey, I want to assign this character. I want to reassign it to something else. Because strings are immutable. And that's what immutable means. It means it cannot change. There's actually only one other type in Python that is not. That is also immutable. And we'll cover that later. But there are only 2 that you have to worry about not being able to change the values of. Now, when it comes to most of the time when you're using variables, it is rare that you'll encounter needing to do this because it's not very common to go over a string and substitute within the string that you're currently using. So for instance, if you were writing some code to validate the characters in a password, or you were doing something that's more common, so almost any site where you can post your own comments, if you notice when you go to post a vulgarity or something maybe rude or crude, it will remove it, or it will replace characters in there with other characters so that you can't necessarily tell what it is. What happens there is they normally do what I did up here where they go over each character in the string. But what they end up doing at that time is they'll say, they have a new name, it doesn't have any value to it, but then they'll go and they'll say new name is equal to new name. So new name is assigned the value of what new name currently is plus the character. And then down here, I can go and print new name. And this one, it's not very exciting. I didn't change any of the characters. But if at this point I had a function called determine character, it took a character in, and I randomly decide to get a random integer here. In this case, I return the character that's passed, otherwise I return the empty string, which was also covered. The empty string represents a string that has nothing in it. So in the same way that you could have a list with nothing in it, you can have a string with nothing in it. So if I run this code, oh, I have to call the function. So I come here and I tell it to randomly get that character and assign it to new name. This is a better example of what might happen when someone's reading over text, that you say make a comment on the New York Times because you read an article and you didn't like what it had. You choose to include characters or words in there that they don't want posted. They would go over whatever you happened, whatever your string passed in, which would normally be a post. In my case, it's my name. They go over it and they determine, okay, I want to remove these. If you notice, I'm not changing the name. I'm getting each one of the values in it. That's common because what they will often do is they'll say, okay, this is what they submitted. This is sort of a cleaned version of what they submitted. And what people get to see are the clean version, but they'll keep around what you actually posted so they have a record of it in the future for whatever purposes the site may need. But in that case, they're not changing the string, so it's still immutable. The string can't be changed, but the variable can. That's the main point I want to get across here, is that this variable, it can have its value changed, but the string, which is being referenced there, that cannot be reassigned. Any questions at all on that? Yeah.
Is reassignments actually be beneficial, or is it just kind of the way Python is constructed beneficial to the developer?
So his question was, is it beneficial to the developer that strings are immutable? And I don't think there is an intrinsic reason that it is beneficial to the developer. One of the reasons that it is actually immutable is because of the way that it represents it all in memory. So what some, you probably don't care, the bulk of people here. But if you saw each one of those when you called the ORD function that had a value, so P is 80, Y is 89, each one of those has a value. What happens whenever you go and you create any one of these strings, what you're creating is a whole list of characters that already exist. And the reason that they do that is so you're not having to go and take up a whole bunch of extra space on your computer or your phone or your tablet whenever you go to run Python. The letter E is defined once. So anytime that character is used, they're all using the exact same character internally. And that's why a string is immutable in Python, because if you were able to reassign that, you would change everyone else's string running in your program. In the same way that when I go and reassign this variable, its value changes. If it were possible to change a string, you would end up changing it for everyone that uses Python on that machine, because it goes and stores each one of those characters and just references it each time it's needed, and that allows it to take up less space on your computer. So there's no intrinsic reason why it would be useful for a developer other than it just takes up less space. The other data that we've not covered that is immutable, it actually does have a benefit, and we'll cover that, I believe, in 2 weeks. Any other questions on the strings before we get on to the studio? Alrighty, so the studio is so I'll talk about the studio as first. I'm going to walk through these first two examples really fast so people have some time to work through this. The goal is that you have a function that you say, is this string sorted? And when it says, is it sorted, it means by those ordinal values that we covered. So if we go up here and we look at what I printed, my name is not sorted because 80 is greater than 76. So my name is not sorted in the way that this function wants it sorted. It wants it to go from least to greatest using those ordinal values. That is a large hint at the implementation options that you can use that actually gets internally whenever so you can compare, like this shows, to set them, sort of see which one comes first. Some examples to get a primer, these two walkthroughs. This first walkthrough is to remove a character in a string. So if I have the word aardvark and I want to remove all the A's in there, it should come out to be this value. So a lot of the examples they've had in the textbook as well as on Vocarium. Well, actually, no, in the assignments on here, they have this test equal. Comes from this test module. So you can go and run this, and it goes and says each one of these passes. Because when you call this remove character function, it goes and removes the A, all A's. From here, it removes all K's, all Z's. This removes all A's from the empty, which is to say it should be equal to empty. This is saying it should be equal to ASDF. If you removed the Z, which there was no Z. And then for this K and A removal, aardvark without any A's, aardvark without any K's. The way that remove character works is it goes and it says, I want to range. So one of the reasons that range and a number of built-in functions in Python return one less whenever you go over them, you go over one less than, is because of things like length that give you the length of what you're going over. So the length of the string that you pass in here is 8. So this is going to make 8 iterations, but because of the way that range works, it's going to start at 0 for this IDX, which is short for index. Apparently typing out index was too hard. And this is another example of taking a string and then reassigning it the value of string plus the character located at this index in the string that was passed in. What this says is that if the character at the current index that I'm on in this for loop is not equal to the character that was passed in, then I'll go and add it to my resulting value that gets returned. So in this case, it goes over aardvark. It says, okay, is the character at position 0, which is an A in this case, not equal to A? So that is false, because it is equal to A. So then it won't add anything in there. And then it goes over it again and says at position 1, is there an A? There is, so it's not going to add it because these values are equal. So you'd want them to not be equal, so then when it finally gets to at position 3, which is index 2, says, all right, R not equal to A, that's true. Go and take my new string, add the empty string plus R, and now I have my first letter, which would be R, and it keeps going through till you get without any A's. So a shorter way to write this, to give an example, you don't actually need to do any of this length and range because, as I showed in the example before, you can say for each character in a string, and you get each character as you go over. And this works out the exact same. So as you work through this studio, which I'll leave up here, is sorted. The goal would be that if you print so if you have something called iString and you set it equal to something like this, and you say is sorted, you pass it your string, you run it, and ideally you would get false because it is not sorted. If you remember the values of capital lowercase letters, it mentioned that as you can get the order of each one, whereas you would expect if you ran it the second time, you ran it with a lowercase, you would expect the second one to be true. And in general, this is actually a pretty good practice if you know you're going to be writing a function and you want it to have certain values come out, to write the kind of, it's called base case, and you can just assume, oh, all the time it's not sorted. So this would have passed a test, but then you know, oh, the second one is sorted. It didn't pass that test. So I need to work on my function to make it work in this case. And that's how a lot of the Vocarium assignments have worked under the covers, is that they have tests that run different scenarios, as you see in your output after you submit each one. So I'll give you all about 30 minutes, 30, 40 minutes to work through getting these sorted. And in that same time, as a bonus in-class work, if you get this finished and want something more to do, if you could make something that verifies a password, meets the 1 uppercase, 1 lowercase, and 1 special character requirement. So if it's past a string, it ensures that it has a lowercase, an uppercase letter, and one of the exclamation point, at, pound. Basically any one of the special characters at the top of the keyboard if you hold shift and just run your finger across the numbers. If you write a function that verifies the string passed to it has at least all 3 of those criteria true, as well as having a length of at least 12. That can be your bonus if you get done with is sorted early. And as usual, feel free to Slack me your answers, and or feel free to put them into, there's another Slack channel that's called In-Class Answers KC that I keep forgetting to click the join button on. I just joined it. So you can send me your answer if you want me to show it and go over it, or you can just post it in the In-Class Answers KC. Try to hold off on posting your answer in that channel until 20 minutes from now, so people have enough time at least to initially work through it. Does anybody have any questions before we get raring on sorting? All right, get excited. Sorting is fun.
Bubble sorts next week.
Actually, no, it's 2 weeks. It's 2 more. And Monday. It is. So you like start.
One or two lines.
That's it.
Let's see. Everything that's just take all
So that example, ABC,
it's neat.
It's out. It's out. When I heard that,
Yeah, there's no charm. But it was mentioned. Charm. Charm. So you can't do this. We should pay any attention to this one. Realize that. I always click on it. It doesn't show any.
The way they have, yeah, they have to install I mean, I guess
Yes, so they say all the time. I'm the one usually do. I'll have my life.
I just had.
Yes. So we have a fund that the reason for that I got like this far, I was like, I'm going to here. So you can wire it.
Yeah, you can just check. Or you can jump on top.
We have like ABC, that's very different. Just as great. But then I is not zero.
So the solution is so I typed these out.
So. Maybe better to all the details. So, 0. And then. So they can do more control. You know right away that that's false.
Yeah, so.
Another fine.
I just tried. I read the instructions.
Yeah, so you have the file. Yeah. So you're like, so but like saying is
Yeah.
Oh, I kind of, sometimes it's making
yeah, I tried.
So they didn't have, that's what was asked as an example, they didn't have any examples. So they didn't have the work on. So I certainly can get the size. Use ABC. I said it to make sure next month I get it.
Why is ABC? Oh, he has an actually very good tracker.
Well, mine's just to fill in details. That's why mine.
Yes, this is it.
Because it screws up the index, right?
Let's see. Oh, do you have a question?
Trying to access from the string module. Shows it.
Yeah, just like slide.
Oh, so that would be a function on a string. Oh,
I believe so.
I think it just or not list a string. It's like if I do it on my computer installation.
What's the name of the function?
No, it's in a string module. And then string dot ASCII underscore lowercase.
So ASCII lowercase. That just returns a list of ASCII lowercase characters. Right. So as an example here in the code I have, so if I import string, I do string.ASCII lowercase.
Well, like in module, because I'm trying to do the password. If I do it in here, it doesn't.
So up here, do you have from string import ASCII?
Well, I just import the string.
Right. So what you would have to do then is access the function on the
Like
module string. Right. So you do string.ASCII
And
lowercase.
then it tells me it's not. I don't know if it's just a problem with that module.
So
I mean, with this.
right.
browser.
So that was one of the things with this. This is another example of where it doesn't have it actually implemented.
Oh, okay.
So what happens here is it's not running a full Python interpreter. It's
I see.
running one written in JavaScript.
Uh-huh.
So it does not have all of the parts.
I think when I played with it before, I must have done it on my computer installation. I didn't realize that was a problem.
Yes, so that's.
All right, thank you.
You're welcome. It's one of the reasons I'm generally hesitant of not trying my examples in there first, is because I end up doing something that's not allowed.
String.
Yeah. But yeah. You don't want to record.
String minus one. So that brings. Yep. Don't want to watch it.
Yeah, well, it's just, I have one question about that. Now, when you say
There's no.
That's all good, man.
Yeah, like this.
Whoa, whoa, whoa. This one's like that sounds like
Character in what's name and just like.
All right, we are gonna start going over the studio. The first answer I'm going to show you is an example of cheating on an assignment by using a built-in function, which is what I did. So there's a built-in function in Python called sorted that will sort any collection you give it. And on a string, there is a function, if you look at the documentation, called join, that will go and take a collection of things and make them all be one string together. So I will go down here. So if we go here and we check these, they come out correctly on which ones are sorted and which ones are not. Oh, the music. Oh, yes. Thank you. Sorry, I left the music on. I'll start back over for the people who are probably unable to hear me. I cheated in my example. I used a built-in function called sorted that is built into Python, and it will do a simple sort for you on any collection you give it. What this join does is so sorted. If you would have taken a quick look, it was on the function page that I showed at the beginning of class for ORD. Sorted returns a new sorted list from the items in whatever you have. It's called an iterable in Python, but when you have a collection of things that you can go over and grab one out of. So if you wanted to cheat and not do the exercise it wanted, you could have used this built-in function. It allows you, so one of the things that's nice about it, it has some extra parameters you can pass, so you can tell it what sort you want to sort, and then also if you want it to go in sort of a reverse order or a normal order. And the reason I'm scrolling is that it was just a wee bit away from the example I showed earlier. If you were looking really close. So if we go and we look at Python string and we do join, so the thing that's pretty interesting here is, I'm not sure why that's the first Google search result, but the second one is the Python documentation. And then the third most Googled thing for Python string, that join that I just used, is a Stack Overflow example that explains how it works. So if I come here and I look at the doc, I go and I search, find this .join function. And all it does is it concatenates all the strings together of the iterable that you passed it, so the collection of things. And it gives a type error if it's not able to make them be strings. So that is what I did here, is I said take an empty string and go and add to it the sorted string that was passed in. If they are equal, then I know the string's sorted, because if I compare a sorted string to a string that already exists, then I know that it is a sorted string. So I cheated, and there are some better examples. Phil sent one. I modified it slightly. Mostly, the modification was I pulled this variable out, so it might be a little easier for everyone to read. So the way this is sorted works is it goes over and it says, all right, I know I want to start at 1 and get all of the numbers up to but not including the length of the string. So if you remember, range, if it was 1 to 10, would go through all of the numbers starting at 1 up through 9. It does 1 less. So the way that this is sorted function works is it says, all right, I want to compare the string that was passed in, and I want to say for in every index starting at 1 up through 1 less than the number of characters in the string. I want to check to see if the previous location is greater than the next location. So what that would mean is the first time you go through here, I is equal to 1. So you'll come through here and you'll do 1 minus 1 is 0. And that tells you, okay, the string at the position 0, which will be the first character in the string, is that greater than the next character in the string? And it will go through each one of those characters and returns false as soon as it hits a character that is out of order. So as you see it execute here, it goes and it says, all right, on the first one, is A greater than B? It is not, so it goes through the loop again. The next time it comes through, it says it's B greater than C, it's not, and then it stops because the length of this string is 3, and it only goes from 1 to 3 with range, which means it only goes over that loop twice, for the number 1 and the number 2. Then the same thing happens for BBC. Goes over there, it says is B greater than B, it is not. And it says is B greater than C, it is not. So it goes and returns true by default, because it went through the for loop, it never hit a return, and then it came down and says return true. So now it goes through on each one of these final ones and returns false, because it comes here and says, is C greater than B? Yes, it is, so immediately return false. And then here, same thing, is C greater than B? That's true, so then it returns false. Then the same for N is greater than this capital B, and then here is lowercase a greater than capital B. I don't actually know that offhand, so that is where, out of curiosity, I would print it. Just to see. All right, so A, that's not a capital B. Let me check capital B. So A is greater than capital B because capital B comes earlier on what is referred to as the ASCII character chart, mentioned a little earlier. So then it returns false immediately. So this implementation, how it may vary from some of the next one I'm going to show you, is that it does what's called fail fast. Is it knows what it's doing is to check to see if it knows at any point that one of the characters is greater than the other one, it can stop. It doesn't go and keep going through every single character in the string. It fails fast. And that's done a lot in various algorithms that run so that you don't end up spending more time doing checks that aren't necessary because all you care about is this string sorted? No, it's not sorted because at least one of the characters is out of order. So then another example. Copy this. What this one does is very similar algorithmically, meaning the way it goes and figures out if a character comes before another, does the same sort of thing. It takes in a string. Where this varies is rather than going over a defined range, like this other one does up here. This one goes over a range. This one goes and says, all right, I know that I can grab each character in the string and I can go ahead and check if my current character is less than the next character in the string. So your first character is going to be in position 0. So it's taking advantage of that fact as it goes through this loop. And it says, if my character is less than this string at position n, which starts off at 1, then go ahead and increase n by 1. So in this case, n will become 2 when you go through here. And if n is ever equal to the length of the string, return true, which at that point will mean that it is sorted. Otherwise, if at any point this will end up going through the whole string regardless, as it goes through each character, and it won't hit this return true until it's compared every character in the string. So this one is figuring out if the string is sorted first. So it's checking through every single character every single time, and then eventually returning true if it is sorted. Otherwise, it goes through here and decides to return false at the very end. So as we saw up here, it's true, true, and then 4 falses. And this one does not return correctly for the second one. It says it is not sorted. Does anyone want to take a stab at why that's the case? Yes, so a lot of people pointed out this should be less than or equal to. And the reason for that is you are comparing the string that came before. So the string that came before can have the same value. And in fact, because in the end what you're saying is if the length of my string is equal to the number of characters that are in order, Ooh. Why is this one not working? I'm gonna keep doing this until it works. It's because it's not using sorted. Should have used that, right? So if you go over each one of these characters, so in this case, we know CBC should be false. So if we come through this character and the first character in the string is a C, what we go and we say is C less than or equal to the string at n, which is 1. So if we come up above, sort of think about how this one worked, how it compared the previous location to the next location. If we start how it did originally and we say less than, so we start at C, we come through, we say, okay, now we have C because it's the first iteration through here. Saying it's C less than B. So this which if you're really curious, you go and do this to see how it evaluates. As we go through each one of the iterations. So if we notice as we go over the characters, we're printing the character and the next character in the string. So this one we print A, and then the next character, which is B. This one we print B, and then the next character, which is C. And then we get the length of added together, and what this is doing is it's adding the next character each time. So that by default, we're starting at 1. So at the point that this reaches the length of the string, it just checks that they're the same length and returns true. What it's not doing is comparing that final character every time. So it assumes that if your first character each time is less, it's going to return it, which we know is not the case on each one of these.
Aren't you accumulating, don't you have in that first section up here, don't you have to start again, the second line goes through? After you have beginning and then like 1, you have to return in after that?
You do not, so we can do a print here and say n has the value of it, n at this point. What I wanted to do here to give an idea of what's happening. So n is increasing each time you go through. So for this first one, it starts off at 1 and goes to 2. Each one of these is only 3 long. So n gets 1 and gets 2 each time through.
So what if you said, instead of, could you just say if string m and then set m to 0 and then put m equals m plus 1? Makes sense? Instead of the character.
So here?
Yeah, because you have, because that's still comparing the third string to the first string. So you have to, so name that string m.
So if I come here, I'm gonna throw that in there so that there's more spacing. So for this ABC, I come through and I print out A. B is the next character. I'm saying 65 is less than or equal to 66. N has the value of 1. And then I go through that loop a second time, and I print out B, and the next character is C. 66 is less than or equal to 67. So then I get true. So where this starts to fall short and I'm going to add a print here. Easier to see. So if I come here, and this is the, we'll go with the ABC example down at the bottom. So as it's going through, you end up, it's B is getting compared with B. So what he was mentioning is changing one of these. Someone raised their hand. Oh yeah. Yes, make this easier. So we know for sure the bottom one is not. So we know when we get to here, so we know we compare A to B, that's fine. We should now be comparing B to C, but right now we're comparing B to B. So right up here, with what I'm printing out here, so I'll go and remove this, and I will only print out. Each time we go through, I'm going to print out the current character and the one that we are comparing to. And then I'm also printing out n so that everyone knows what that value is whenever we're doing the comparison. And I will actually print it out before the if statement so that we know what it is in case that doesn't evaluate the way we want it to. I removed it.
And to iterate up, whether it passes the if statement.
So this is returning false. Oh. Hold on. I accidentally tabbed something in incorrectly there. Okay. I hit a thing on my keyboard. That's why that shouldn't have been returning how it was. So this is what the code was before I messed up on my keyboard and I tabbed this in.
The return needs to indent one more. Another, the return false needs to indent another space.
Right, so if we indent this return here, this will return false at any time that the first character is not less than or equal to the next character. Which will make it do what the other function is doing. However, so I'll comment these out so that we can see the output of just indenting. So now that returns false every time because it comes to the next comparison and it doesn't get it.
But if you had it as else, it would be right.
So the main reason I keep going over this example is that I want to show whenever you program day to day, like this, these are common mistakes to make. And it's very easy to, so one of the reasons to add all these print statements, this is something you might do while you're actually writing code to see where is this going wrong. And you know where it's going wrong because n is 1, and then it's 1 again. And n should not be 1 again. We know that we only want to do the comparison twice, but we're doing 3 comparisons here. And what happens each time it goes through here is it goes through and it says, okay, for each one of these characters in this string, I'm going to go and compare it to this n value. So it says, is A less than B? Well, that's false, so I'm going to go through again. And then what it says, is B less than or equal to B? Oh, that's true, so I'm going to go and increase the string. And because of how it happened to work out with C here, so now it went through again. At this point, n is given the value of 2. So then it goes and it gets the 0, 1, 2 position of C here. And it says, okay, so now is C, which is the last character, less than or equal to C, which is true. So it increases n by 1, giving it a value of 3. And so what it says here is, oh, if n happens to be the same length as my string, return true. But But what shouldn't happen, what the problem with what's happening here is right here. This, in the event that this is not true, we know that we have a character coming before another one that is further in the ordinal values. So as Reggie mentioned, this needs an else statement to immediately return false so that you know that you've compared the wrong values. So now when we do this, we go through once, it's false, as it should be. So if I come up through here, we know these last two should be false. As we come through here, we know the first two should be true, and the last four should be false. The key problem was that in this if check, it didn't handle the scenario where this evaluated to false. And it had a potential, it wouldn't always happen with everything you tested, but if you got to the point where your last character was going, if only one of your characters was out of place, you ended up getting in as the same length as your string if only one character was misplaced. So this is an example of sort of why those various different tests on Vocarium happen that test against your code is to test out to make sure that in all likely cases, whatever function you've written produces the correct results. So this one was close, but it actually specifically was incorrect in the scenario where one letter in the string was out of order. Because it would go through and still compare each one, and that's where we saw it comparing B to B and C to C. They were less than or equal, so it returned true because you ended up with the same length. Oh. That's fine. So this one, we'll call it, so this was the bonus. I'm going to rename the function isValidPassword because it returns a Boolean. So what this one does is we had the three different things we know we wanted to check. We wanted to check to see if it had an uppercase letter, a lowercase letter, and a specific character in it. And then this other check here is all of, they just made a string of all of the special characters. And what this does is for the string that you pass in, it says, I'm going to go over each one of these strings. And then what this says is if the ordinal value of this character is greater than 65 and it is less than 90, then it is a valid password. And for those that are curious, you can, there's a char function that lets you go backwards. So if you want to know what each one of these is equal to, so we have 97, and then 122 is the other. What might be referred to oftentimes, so you might have heard people say things about magic numbers or magic strings. What that means is you have a hard-coded value in your code that doesn't really mean anything when someone goes to read it. So that's 65. If I didn't go down here and print it out, I have no idea what that is. I have no idea what that 90 represents. But when you come down here, what you can see is that it's saying, so that first one, the 65, is capital A. The 90 is capital Z. Remember I mentioned that ASCII table? What happens is every letter that is between 65 and 90 inclusive is between capital A and lowercase and capital Z. So as soon as that happens, as it goes through these strings, it knows, oh, you have at least one uppercase character, so the upper check is set to true. Next, it comes through here and it says, is your character between the lowercase a and the up to 122. An interesting tidbit here, the reason that the capital letters come first is that whenever terminals were first created, all they did was use capital letters. So they had no need to go past, they still use some other special characters, which is why you see a difference there of 6 possible values. They didn't use lowercase letters, so they didn't need to go above the 96th character. Whenever the terminals were first created. As they added more characters and wanted to be able to use lowercase characters, they then started filling in each one of those values. So if you pull up, so if you're curious on these, you can pull up an ASCII map. And what you can see is, so right here, this capital A maps to 65. So if I come over here, capital A maps to 65. So you can go through and you can see that. You can find ASCII maps to see the range of characters, and they're always sort of in a row like that. So then this last check here, where it ends up setting this true, is it says if char in char list. So this is the set of characters, the list of characters that went made up here. For each one of the special characters, it says if the character I'm currently checking in the string that was passed in is one of these special characters, set that char check equal to true. And then, so you keep going through each character in the string, and you may or may not end up setting these values. And then at the very end, it goes and returns the value of upper check and lower check and char check. And if you remember what and does, is what that ends up saying is if upper check and lower check are both true and char check is true, then the is valid password will return true. So here it returned false because it is not a valid password. But if I went and did something like that, it will return true because I have a special character and a capital character in there. And this, so this exact function may or may not be in someone's code base, but it is quite common to have this pattern of setting up checks, going through a list of things, setting those checks, and at the very end saying, if all of the checks I have are true, go and do something. So in this case, you're saying, if all of my checks are okay, then they can go and use this password. The other check that I was sort of wanting, and you could add here, say, and length of string is greater than 12, in which case that returns false. So I have to go and add some extra stuff on there, and then it's true, because the length of it is greater than 12. Just a little fun fact about password security. The length of your password is more important than almost anything else about your password. Just as a little fun fact for the evening about passwords. But that is all I have, unless there are any questions. All right, I will post this like I normally do on the class, and I will also post the link to the video. I've been doing that. There are like 20 and 30-minute segments of the video that are silence. That's because I'm not talking in front of the computer, and the microphone's right here on the computer. But everyone have a good evening, and I will see you Thursday. Remember, there are 2 assignments due on Sunday, so if you want to start getting a move on those.
Yes. That return that you did on the second one with the and.
Which
That
one?
was very clever. That's what we could have done in the first one. We could have gotten rid of that whole if there, I think,
Yes.
and just done a return instead of that final return false. Since the whole idea of this one was to go through the whole thing, is if there was something we needed to do the whole thing,
Right.
rather than just do like sort it or the other way. But I didn't see that until you showed the return and that you could just grab all that because you're testing it over and over again.
Right. That's sort of why I like to show.
Yeah, that was kind of odd. I hadn't thought about returning. Just just checking if it's true and then returning true. Yeah, I like that. Cool. Yeah. Now, and I was going to ask you did this ordinal thing just to show us, but we know that there's no other characters between A through Z.
Right.
Either lower or up.
Yes.
It just runs continuous from that starting point.
Yeah. So right here, if we start at capital A, it goes through to capital Z, and then you end up with those bonus characters,
Yeah.
and then
And then A starts up. And then,
A through Z, and then a couple
Yeah.
more bonus characters up through 127, which is where it stopped for a long time.
yeah. I didn't think of doing it that way. I don't know why. I just ended up testing the input character, whatever it was. I just tested on if it was equal to the same character but uppercase, and then the other one was lower. And I did this. I'm still thinking there's some way to do it with a counter though, where you didn't have to do the test, as if you could
Oh,
just
right,
do some kind of simpler, like you were trying to make it really fast, just for the fun of it. I'm gonna have to do that.
Which you could, so you could do that in
It's just 'cause the number thing. I mean, but the problem is you'd have to exit out of that 4. I don't know how to.
Right.
I'd want to.
There is a way to exit out of the 4 early, and I deleted it from the person's code example.
Yeah,
So it's using what's called a break statement.
Pass, because on the studio thing, I had my if different where I needed to just no op kind of deal.
Right.
I can't remember that it's passed. I can just continue.
There's a thing called a break statement,
It is,
and
break.
that's where you could. So what was originally here was if all of these were ever true, go to break. So that you don't have to go through the whole string if you don't need to. But I removed it because we haven't covered break.
Yeah.
You're welcome.
How you doing? So, do we not have about
I don't believe so. I believe Joshua will end up being your teaching fellow going forward. I thought I was going to get finalization on that today, and I did not. I believe that is the case, though.
So I guess the next 2 assignments after Sunday or July of that person is.
Yes, so Joshua will be filling in for Alec as long as he's not here,
Okay.
and it is likely that Joshua will be replacing him.
Okay. So you're, I don't, you're cool.
Yeah.
Yeah.
I think they'll be fixed soon.
This runs or